Okay, these are the 6.5 notes, the properties of logarithms. Page 1 is primarily the properties, but I do want to make sure that we highlight and remind ourselves of a couple of things. So first off, properties of logarithms are what we can use to separate and combine logarithms that have got more complicated expressions involved. Okay, so we have the zero exponent rule. Keep in mind, logarithms are the inverses of exponents, and so anytime we have got an exponential that looks like this, and this goes both ways, we can always write it as log base b, same b, of the answer equals the exponent. The logarithm is the exponent. So here, if we think about this log base a of 1 and we rewrite that as the exponential, that means any base to the 0 power equals 1. We know that's true. Okay, so this makes sense. Property 2, log base a of a equals 1. Any base a to the power of 1 equals just that base. So that one also makes sense. There is an exponential way to show the next one, the product rule. Keep in mind, if we multiply two numbers that have the same base, that's what we're doing over here. We're multiplying two numbers that have the same base. We add those exponents. That's all this is saying. When you multiply two numbers that have the same base, we are adding the exponents. That's the product rule. When you are dividing two numbers right here that have the same base, we subtract those exponents. So it goes right back to what we know about rules for exponentials. And then the power rule, you'll find this one very useful when we are taking the log base anything of a number to a power. Remember that when we take powers to powers with exponentials, we multiply those. That's what we're doing here. We're taking a power to a power. We're multiplying those two powers. Sometimes the most difficult thing to remember is the equal sign does not mean we're going one direction. It just means what we have on both sides are equivalent. So sometimes you will have expressions that look like the left-hand side of the equal sign, and you're trying to make them look like the right-hand side. Sometimes you'll have the right-hand side and you're going back to the left. Okay. So there are some guidelines here if you would like to go through those. Typically I follow those. Sometimes I deviate if something else seems to make more sense. So example 1. We want to expand log base 3 of x squared times y squared. So we are going to start with the product rule, property 3. And I'm going to rewrite this as log base 3 of x squared plus log base 3 of y to the 7th. That's not completely simplified. Now we're going to go to property 5. That product rule, we're going to take that exponent and pull it out front. We got 2 times log base 3 of x plus 7 times log base 3 of y. Sometimes it's easy to get confused and decide if it's a good place to stop. But we can't do anything here without going backwards. I was going to try to make this all one recording. Might as well keep going. So example 2, we are expanding log base 7 of the square root of x over y to the 3rd. We've got a quotient, so the first thing I'm going to do is rewrite this, and I know this is a little out of order from above, as the subtraction, the difference. And then I'm going to remember that the square root can be written as a fractional exponent. And then I'm going to use the power rule. And then I'm going to make sure that I write smaller next time. So I got 1/2 log base 7 of x minus 3 log base 7 of y. I know it's time to stop where I've got x or y, whatever my variable is, by itself in the argument of that log. Keep in mind, this is not 7 times x. That 7 tells us what base we're working with. X is the argument. Next one, we are expanding log base 5 of 5y over x to the 4th. What I would do if I were you at this point, if you feel comfortable with it, hit pause on the recording, come back, and check your answer. So again, I'm going to take this piece by piece. I'm going to separate, log base 5. I got log base 5 of x to the 4th. I took care of the quotient and wrote that as a subtraction. Okay. Next thing I'm going to do is notice I'm going to do two different things in the same step. I know that I've got a product in here. I got log base 5 of 5 times y. Sometimes we forget that coefficient is separate. These are being multiplied, so I add here. Minus, and I'm going to go ahead and use the power rule on this one. 4 times log base 5 of x. Okay, now, I am going to go back up to property 2. Log base a of itself is always 1. That's the very first thing I have, log base 5 of 5. So I end up with 1 plus log base 5 of y minus 4 times log base 5 of x. Now, it feels like we're making things more complicated and not less, but if I have to solve for an x, I need to isolate it, I need to get it by itself, and this is the first step to doing that, right? I'm writing a log expression with a single variable. Now I'm going to show you a little trick on example 4 here. You can pause, stop, do this, and come back and see if my trick is actually helpful. We'll use it on 4 and 5 and 6. So in example 3, I separated the quotient, numerator and denominator, and then I had to separate apart that numerator. Notice that anything here, and you can do this the long way and confirm that I'm correct. I want to do this. Anything in the numerator is going to end up being added. So I'm going to do two things just because I have limited space. I'm first going to take that 4th root of x to the 3rd, and I'm going to write it as x to the 3/4. And then I'm going to add that log of w to the 9th. Okay. Both things in the numerator are being multiplied. Those are going to be added. Notice here, we don't have a base, so we know this is a common log, which is base 10. Now I'm going to subtract off any logs in the denominator. I get 3/4 common log of x plus 9 common log of w minus 13 common log of z. Now, do I have to say common log every time? No, you could just say log x, log w. But be careful that you're only not using a base if it is either the common log or the natural log. We're going to do the same thing on 5. We got the natural log of e to the 2nd. There's my numerator. Now, I could subtract the whole denominator, but in reality what's happening here, anything in the denominator just gets subtracted. Right? If I did minus that whole denominator and added them, I'd have to distribute that negative anyway. I get 2 times the natural log of e minus 2 times the natural log of b minus 2 times the natural log of c. We know the natural log of e is 1. That's basically log base e of e. So I get 2 times 1, which is 2, minus 2 natural log of b minus 2 natural log of c. If you were solving for something, yeah, you could divide out the 2. Right here, doesn't really matter. We are going to do the same thing on example 6. I got log base 2 of 1, there's my numerator, minus log base 2 of x to the third minus log base 2 of y to the third. Log base 2 of 1, that feels like one of the properties. If I go up, I see that's property 1 here. Log base anything of 1 is just 0. So I get 0, I'm not even going to write that, minus 3 log base 2 of x using the power rule. It should be y squared. Minus 2 log base 2 of y. Now remember, at the beginning of this video when I said we could go both ways, example 7 is going to have us look at these the other way. Okay, we want to write these as a single term. So first thing I notice is that I've got this coefficient on my log base a of c. So I'm going to use the power rule there. First one is log base a of 2. I'm not even changing that. I'm just rewriting it. Plus, I got log base a of c cubed. These are being added, so I know I'm going to multiply those arguments, and we're going to write this as log base a of 2 c to the third. Now, some people like putting these in parentheses so we don't get confused. Make sure that your writing is not super sloppy and it doesn't look like log a times 2 times c to the third. That a is our base. It has to look different. So again, I have a power, number 8, writing as a single term. I'm going to leave this first one out. I'm going to write the second one. Sorry, I got distracted there. Log base 2 of x squared. Now, log base 2 of 4, that means what exponent do I need onto to make 4? That's just 2. So I get 2 minus log base 2 of x squared. But notice that's not what this is asking for. This wants this written as a single term. Sometimes you got to go back and see what it is you're being asked to do. You want this written as a single term. It's a subtraction, which means my arguments are divided. Log base 2 of the quantity 4 over x squared. Same thing on 9, simplify by writing as a single term. You know what I'm going to do? I am going to, never mind, we're going to leave it like this. That gives me log base w of 7 to the 1/2. I will rewrite that as a square root when I combine these. I got log base w of x to the 1/2. I've got 2 square roots, which means I'm probably going to be able to put them under the same square root, minus log base w of y. And just so I get in that separate step, because I know that rewriting rational exponents as radicals is something that we don't do enough. Y to the fourth, I left that exponent off. What I get here is log base W. Now I've got square root of 7 times square root of x in the numerator. I'm going to combine those in one step. I've got y to the fourth in the denominator. Again, it doesn't hurt to put parentheses around it, especially if you are not writing on lined paper or you're rushing and your handwriting is not as neat as it could be. Okay. So example 10, a little more here. I got log base a of 2, and then notice I'm subtracting 3 things. The 3 log base a of c, the 7 log base a of x, and the 1/2 log base a of m. Those subtractions tell me that all of those terms are going to end up in the denominator. So I got log base a of 2 minus log base a of c to the third minus log base a of x to the 7th minus log base a, and I'm going to combine these now, square root of m. M to the 1/2, square root of m. I get log base a. 2's in my numerator. Over, we got c to the third, x to the 7th, square root of m. Again, anything that was subtracted ends up in the denominator. Page 3 is empty. Sorry, apparently I couldn't figure out a way to remove that. So I apologize for the disappointment.